In this video, I'm going to take you through all of those worded questions from 6.3. Okay, so if you're having trouble with a certain one, you can skip to that. Otherwise, I'm going to go through all of them and just watch the ones that you need pretty much. So this first question, a ship was meant to travel north. It veered off course and went north 80 degrees east. So that's that line there for 280 kilometres. Okay, and we've got two questions there. How far east did the ship travel and how far north did the ship travel? So it gives you a guide up here. Any lines that are going directly upwards, they're heading north. So here, north. Any lines heading horizontally are east. Okay, so to answer that first question, I'm going to kind of copy the diagram, which is good that they've given us a diagram, and use the information that's useful for me. So I've got 80 degrees, 280 kilometres, and I'm trying to find how far east. So that's here. Okay, so I'm going to label that E for east, and that's what I'm going to try and find. So I've got my angle here, I've got the opposite side and the hypotenuse, so I'm using sine. Okay, and I'm going to plug in the information that I know. So I know the angle is 80 degrees. Opposite, that's what I'm trying to find. And the hypotenuse, that's 280. Okay, and then I have to rearrange. So my variable is on the top. Okay, at the moment it's being divided by 280. The opposite of dividing by 280 is timesing by 280. So 280 times sine of 80 degrees. So I've got to here without using my calculator. Now I'm going to need to use it. Just ignore my calculator. This is from year 11. So 280 times sine of 80, 275.75. Okay, if you're getting answers different to this, or if you've got a negative answer to this first one, your calculator's in the wrong mode. Okay, it's calculating in radians and not degrees. So if you're getting like negative 278, I think it is there, your calculator's in the wrong mode. So this was a worded question. It asked me how far east the ship travelled, and I need to answer in words. So the ship travelled 275.75 kilometres east. That's an important step. If it asks you in words in plain English, you need to answer in words in plain English. So let's do B. And this is exactly how I'd set it out. Okay, I'd copy the diagram again because we're looking for different information this time. Okay, so I'm looking for how far north. So straight up, we're looking at this side here. I'm just going to label that N. Okay, so looking at my angle, I've got my adjacent side and my hypotenuse, so we're doing cos. Okay, if at any point you want to pause this video and kind of work ahead and then use it to check it, you can. So cos of 80 degrees, my adjacent is my north, my hypotenuse is 280. At the moment, it's on the top, it's being divided by 280, so we're going to do the opposite, which is times in by 280. Okay, so I get to there without having to use my calculator. So 48.62. 48.62. And again, word the question, worded answer. So the ship travelled. Their handwriting's a bit neater than mine. 48.62 kilometres north. Okay, and if I was in class, I would just check that quickly. So I've got Jack Plus open. So we've got 275.75 and 48.62. Oh, you can't quite see that. Question 9, 275.75 and 48.62. So yep, all good. Okay, so this is another worded question. Again, it gives us a diagram, which is really, really helpful. So let's read it through. Rescue helicopter spots a missing surfer drifting out to sea. The helicopter descends vertically to a height of 19 meters. So vertically, up and down, 19 meters. It drops an emergency rope, which the surfer grips, but due to the wind, the rope swings at an angle. So this is the rope here. Okay, what is the length of the rope? So we're looking for the length of the rope. First thing I'm going to do is just pop an X there. Okay, so that's a pretty good diagram. It's pretty clear. If you're having trouble with it, you can copy it out so it just looks like a normal triangle. Okay, and then proceed as normal. So I'm going to have a look at what sides I've got here. My angle's there. I've got the adjacent side and the hypotenuse. So I'm using cos. Okay, I know my angle, 27 degrees. My adjacent is 19. I should write that a bit better. 19, and my hypotenuse is x. Okay, my hypotenuse, my variable is underneath. It's down under, so I'm going to switcheroo. I'm going to swap that to that. So x goes out the front, and where x was, I'm going to put cos of 27. Okay, so I've gotten to there without a calculator. Now I need to switch over to my calculator. And I'm going to use a fraction bar if I can find it. There. Okay, so up the top I've got 19, and down the bottom I've got cos of 27. So 21.32. Okay, it's a worded question, so we need a worded answer. So the question asks us, what is the length of the rope? The rope is 21.32 meters long. Okay, so every time you get a worded question, you're going for a worded answer. I'm going to check my answer there. So this is question 10. 21.32 meters. Yep, all and done. Okay, so walking along the coastline, Michelle, who is at M, so down here, looks up at an angle of 55 degrees and sees her friend Helen on the top of the cliff. So M sees H, Helen there. Okay, how high is the cliff if Michelle is 200 meters from its base? Okay, so Michelle is 200 meters from the base of the cliff. We're trying to find out how tall the cliff is. I'm just going to copy that diagram. Okay, so Michelle's there, Helen's there, 200 meters from the base of the cliff. The angle is 55 degrees. We want to find out how high the cliff is. Okay, so it's that one there. So I'm just going to pop an X there. Okay, and then we're trying to find X. So we've got 55 degrees here, we've got the opposite side, and we've got the adjacent side. So we're using tan. Okay, so I've got my angle there, and then my angle is 55. My opposite side, I don't know, that's X. And my adjacent side is 200. At the moment, X is being divided by 200, so the opposite of that is timesing by 200. Okay, and once I've got down to there, it's time to plug it into the calculator. So 200 times tan of 55. 285.63. 285.63. So worded question, worded answer. How high is the cliff if Michelle is 200 meters from the base? So the cliff is 285.63 meters high. And we'll check the answer for that, 285.63, 285.63. Okay, so they're starting to get a little bit harder now, but they've still given us a diagram, which is good. So we're trying to calculate the width of the tile W. So we're trying to find that length there. All right. And we've got a parallelogram. So I'm just going to redraw it so I can scribble all over it and see it a little bit better. So that's 48 there, that's 122, and we're trying to find pretty much from one side to the other. Okay, so we could make this into a triangle. Okay, I can see a triangle there. Okay, and I can also see a triangle there. So there's two ways that I can do this. Okay, if this side is 48, this side must be 48 as well. Okay, and if this angle is 122, this angle is 122 here. Okay, so I can do this a couple of ways. The way I'm going to do it, I'm actually going to split this up so that I've got the little angle in the corner. Okay, so it looks like this. Okay, and that's 122 degrees, but I already know that that's 90 there. Okay, so if I take away 90 from 122, I'm going to get the little angle in there. Okay, so take 90, leaves us with 10. So we've got 32 degrees in that little corner there. Okay, once I've got that, I can kind of just copy down my triangle, okay, from here. So I've got 48, I've got 32, and I'm trying to find the width. So I'm trying to find the W here. Okay, that's the hardest part. Once you get that diagram of a triangle, you should be right to go from there. So I'm having a look at that. I've got the adjacent side and the hypotenuse, so I'm going to use cos. Okay, I know my angle, it's 32. My adjacent is what I'm trying to find, W, and H is 48. So at the moment, W has been divided by 48, so the opposite of that is times it by 48. Okay, and then I need my calculator. So 48 times cos of 32, 40.71. 40.71. Now, this asks us to round to the nearest millimetre. Okay, so that would actually be 41 millimetres. So the tile is 41 millimetres wide. Okay, you should probably write it so it's readable. Okay, and that's the answer. So the hard part there was getting this angle in here. Okay, so a pole is supported by two wires. Okay, so this is the pole going down here, and it's supported by two wires, so it's tied on by two wires. If the length of the lower wire is 4.3, length of the lower wire, so that's that one there, I'll just pop that there, 4.3 meters. Calculate to one decimal place the length of the top wire. I'm going to make that X. And the height of the pole, so I'm going to make that Y. Okay, so a couple of steps here. Okay, these are the hard ones where we've got to kind of do a couple of steps to get where we want to go. So first of all, we've got to find the length of the top wire and the height of the pole. So if we had one big triangle here, okay, one big triangle with Y and X, and 48 plus 13, 8, 9, 10, 11, so 61 degrees here. Okay, if we could figure out one of these sides, it would give us all the rest of them. So we've just got to find one of those sides and then we can find X and Y. Okay, we've also got the little triangle down here, okay, with 48 and 4.3. Okay, so we could use that to find this here. Okay, I'm going to let it be A, which gives us that there. Okay, so you're trying to think to yourself, what can I find? What can I do? And work your way through from there. So I'm going to find A, and then I'm going to use that to find X and Y. So looking down here, I've got the adjacent and the hypotenuse, so I'm going to use cos. Okay, and my angle is 48 degrees. My adjacent is A, that's what I'm trying to find, and my hypotenuse is 4.3. So at the moment, my variable's been divided by 4.3, so the opposite of that is multiplying by 4.3. Okay, and once I get to there, I'm looking for my calculator. 4.3 times cos of 48, 2.88. Okay, so 2.88 meters. Okay, so now that I've got that, I can find x and y. So the first thing I'm going to do, I'm going to look at my angle, and let's go for the length of the top y. Let's go for x first of all. Okay, so I've got my adjacent here, and I want to find my hypotenuse. So I'm going to use cos again. Okay, cos of theta equals adjacent over hypotenuse, cos of 61 degrees equals adjacent, which is 2.88, over my hypotenuse, which is x. Okay, and because my variable is down under, I'm going to switch a root. So I'm going to change these two over. So x is going out by itself, and cos of 61 is going at the bottom of the fraction. Okay, fraction bar. So 2.88 over cos of 61 degrees, which is 5.94, and they want it to one decimal place, so 5.9 meters. Okay, but it didn't ask us to find x, it asked us to find the length of the top wire. So the length of the top wire is 5.9 meters. Okay, so that was A. Yeah. Okay, so the length of the top wire is 5.9 meters, and I'm going to pop that in here too. So that's 5.9 meters, not x anymore. Okay, and then I've got to find the height of the pole, which is y. So that's B. Okay, I'm going to look here. I've got my angle, I've got my hypotenuse and my adjacent, and I'm trying to find my opposite. So I need a ratio that takes into account the opposite. So color. Okay, I could use sine because I'm trying to find the opposite and I have the hypotenuse. I can't use cos because that doesn't include the opposite and I want to find the opposite. Or I could use TOA. I'm going to use TOA just because I haven't used it very much yet. Okay, but you could use either. Okay, either one will work there. Just opposite over adjacent. Okay, I know what theta is. Theta is 61. Okay, my opposite is y. My adjacent is 2.88. And my variable's on the top, it's being divided by 2.8, so the opposite of that is timesing by 2.88. Okay, and then I just need my calculator. Okay, to one decimal place is 5.2. So the length of the pole, sorry, the height of the pole is 5.2 meters. Okay, and that's done. Just going to check our answers, which is over here. Sorry, which question was it? So question 16. So 5.9 meters and 5.2, 5.9, 5.2. Okay, this is the last one, question 17, and it's going to be very lengthy, so just bear with me. So the frame of the kite is built from 6 wooden rods. We've got 1, 2, 3, 4, 5, 6. And we need to calculate the total length of wood used to make the frame of the kite. So we've got to find 6 individual sides, and then we've got to add them all together to get the total length. Okay, so there's going to be a lot of working out, and how I'm going to organize my working out is I'm going to label each side, and then I'm going to do it one by one and add them up at the end. So I'm going to make this, doesn't matter which way you go, this is going to be 1, it's going to be 2, it's going to be 3, it's going to be 4, the long one's going to be 5, and across the middle is going to be 6. Okay, I already know 6, it's 42 centimeters. Okay, so I'm going to start, I'm just going to start with 1. Okay, and I'm going to draw a little triangle, showing the diagram. It's 62.5 degrees, it's right angle. I'm looking for 1 here, I'm going to make that X. And I need one more side. So I don't know what this length is here. I do know that this is 42 meters, so half of that, 21 meters, I've got that there. Okay, so I've got my adjacent side, my hypotenuse, I'm using cos. So cos of 62.5 equals adjacent over hypotenuse. Okay, the variable's down under, so we're going to switcheroo. So x equals 21 over cos of 62.5. I'm sorry this is messy and so small, I'm just a bit worried about running out of room. Okay, and calculator is going to be 21 on the top, cos of 62.5 on the bottom. I'm going to round to 2 decimal places the whole way through, and then I'm going to round to the nearest meter right at the end. So I've got 45.48. 45 point, already forgotten it, 48. Okay, so I've got 1. Okay, this is symmetrical. So 2 is going to be exactly the same as 1. I would say this is a bit of work. You can calculate it if you want to, but it's going to take a bit of time. And the same is going to go for 3 and 4. If I can find 3, 4 is going to be exactly the same. So what information have I got? I'm going to copy down my diagram again. So 74.1, I've got a right angle. I'm trying to find 3, and I've still got that side as 21. So I've got my adjacent and my hypotenuse. I'm using cos. Adjacent over hypotenuse. Again, my variable's on the bottom, it's down under, so we're going to switcheroo. 21 over cos 74.1. Okay, and that goes in my calculator. So 21 over cos 74.1. 76.65. Okay, and then I've got number 3. So number 4 is going to be exactly the same. Okay, and I've just got to find number 5 because I've got number 6. Okay, so number 5 runs all the way down the middle, so I could reuse these diagrams. Okay, and I can plus those sides together. So I'm just going to draw another diagram. Like I said, this is a messy one. This question, it's quite lengthy. I'm going to draw, oh, that's terrible. I'm going to draw my diagram. Okay, I'm going to find A and B, and A plus B is going to give me 5. Okay, so I've got 62.5, 21, and I've got 74.1 in there. Just bring that out there. Okay, so to find A, we've got the opposite and the adjacent, so we're using tan. So 62.5 equals the opposite, which is A over 21. A is being divided by 21, the opposite of that is timesing by 21. Okay, so A equals 21 times 10 of 62.5, 40.34. Okay, and then I'm going to try and find B. So I've got opposite over adjacent again, so I'm using tan. This time of 74.1. Opposite over adjacent. B is being divided by 21. The opposite of that is timesing by 21. Okay, so B is 21 times 10 of 74.1, 73.72. Okay, so A plus B, 40.34 plus 73.72, 114.06. Okay, so it's 5, and then we know that length 6 is 42 because we've already been told that. Okay, time to add them all together. So we've got 45.48 plus 45.48 plus 76.65 plus 76.65 plus 114.06 plus 42. Okay, so can you see there, even though my writing was a bit messy, my setting out was very logical. Okay, I labelled them and I went 1, 2, 3, 4 all the way through, so I didn't miss any sides. 45.48 plus 45.48 plus 76.65 42. So I've got 300.32. Okay, and they wanted the length of the wood used to the nearest metre. So length of the wood to the nearest metre is going to be 300 metres. It's 300 metres. Okay, this is question 17. Let's check that. 4 metres. What have I done wrong? Okay, so I've done this last step wrong. What I didn't realise is this is all in centimetres. And I've written it in metres. Okay, so they're centimetres. And that one as well. Okay, so I wrote them in metres, which is why my answer is wrong. So I'm going to go back and change that. Okay, so that these are centimetres. Okay, the other thing I'm going to do is it asked me to round to the nearest metre. Okay, so what I've done there, I've used 2 decimal places. Okay, you would get marks for doing it like this. Okay, the answer in the book actually rounded up here. Okay, so if I did it like this, 300.32, I would get 3 metres. Okay, and if I rounded earlier, I would have got 4. Okay, and I'll show you how that works. So if we do it in blue, let's round it earlier. So we've got 45 plus 45 plus, that would be 77, rounding up, plus 77 plus 114 plus 42. Okay, so 45 plus 45 plus 77 plus 114 plus, oh, I missed, 77 plus 114 plus 42 gives me 400 centimetres, which is 4 metres. Okay, this one here gave me 3 metres. Either one in a test, you'll be marked right. Okay, so if you're trying to get the textbook answer, it's there, you have to round a bit earlier. Okay, but if you got to here or close to here with a little bit of different rounding but ended up at 3 or 4 metres, you've done it correctly. Okay, so that's the end of this video. That's all of those 6.3 questions, and I hope it helped.